Welcome back to another video. It's Dr. Tarcia Hubert, and in this video we are going to be talking about applications of radian measure. Okay, so in the previous video we actually talked about radian measure, which is another form of measuring angles. So the most commonly used form is degrees, and now we also know about radian measure. We learned how to convert from degrees to radian measure, and also vice versa, how to convert from radian measure to degrees. So in this video we're going to talk about just different applications, real world problems that would actually involve radian measure. And the very first thing is, if I can get my screen to work here, the very first thing is arc length. Okay, so arc length is a measurement of the length around the circle. Okay, so I have a circle down here, and let's look at the red portion right here. So say I wanted to measure this part right here where I'm tracing my mouse, that would be considered an arc length. Okay, and it says the length S of the arc intercepted on a circle of radius R by a central angle of measure theta radians is given by, and here's the formula. So if we want to know this arc length, we need to know what is the radius of the circle and what is the angle that is formed from that arc. Okay, and we will find that by taking the radius and multiplying it by the angle. Now what's really important here is that the angle has to be in radian measure. It has to be in radian measure. So if you get the angle in degrees, you have to convert it to radian measure in order to use this formula. So you will find the arc length by multiplying the radius and the angle. Let's look at a couple of examples. Example 1, we have a circle that has a radius of 18.2 centimeters. We want to find the length of the arc intercepted by a central angle of, and it has two parts. The first part is part A, 3 pi over 8 radians, and the second part is 144 degrees. So let's just start with part A, 3 pi over 8. And so we know that S is equal to R times theta, and theta has to be in radians, and in this case our theta is in radians. So to find it, we will just do 18.2 centimeters times the 3 pi over 8. And you could just plug that in your calculator. Remember, plug that in your calculator, multiply it out. And if you multiply that out, you get a total of 0.44 centimeters. Okay. And since the radius is measured in centimeters, then that arc length will also be considered centimeters. And so that's how you find that arc length. You do the 18.2 times 3 pi and then divide it by 8. Okay. So that's for part A. Now for part B, it wants us to find that same arc length with the same radius or on the same circle, but this time the arc is formed by a 144 degree angle. So in this case, our angle theta is in degrees and we have to convert it to radians. So theta is equal to 144 degrees. And remember, to convert from degrees to radians, we will multiply by pi over 180 degrees. So if you multiply that by pi over 180 degrees, you can actually simplify that. 36 goes into 144 and the 180. If you divide 144 by 36, you get 4. You divide 180 by 36, you get 5. And so this simplifies into 5 pi over 4. So our 144 degree angle becomes 4 pi. I think I said 5 pi over 4. That's supposed to be 4 pi over 5. So that simplifies to 4 pi over 5. So now that we have our angle in radian measure, now we can find the arc length by doing R times theta. Our R is 18.2 centimeters. Our theta now is 4 pi over 5. And so this is what you will plug in the calculator to get the measure of the length of that arc. You'll do 18.2 times 4 pi and divide it by 5, and you will get approximately 45.74 centimeters. Okay, so that's how you will calculate that arc length that is formed on a circle of radius 18.2 and an angle of 144 degrees. So the main thing here is that when you use the arc length formula, your angle has to be in radian measure. If you have any questions whatsoever about finding arc length, please put them in the comments below and I will respond. Okay, let's look at another example. In example 2, Reno, Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north, while the latitude of LA is 34 degrees north, and that means north of the equator. And then we know that the radius of Earth is 6,400 kilometers. We want to find the north-south distance between the two cities, okay? And we have an image here that shows us what's going on. So we know that the Earth is round, and so we end up on a circle. And because we end up on a circle, we end up using arc length to find the distance, all right? So we know that Reno is 40 degrees north, and that's north of the equator. So we would go 40 degrees north, and that will give us the location of Reno on the Earth. Latitude location, okay? And then we know that LA is 34 degrees north. So if we measure 34 degrees up from that equator, then that will give us the point of Los Angeles. And so now we want to know what is the distance between the two. So we want to know what is this arc length right here in between Los Angeles and Reno. And so we will measure the difference between the 40 degree and the 34 degree. And that gives us 6 degrees. So we're actually looking for an arc length that's formed by a 6-degree angle. And we know the radius is 6,400. So the first thing we need to do is convert our theta, which is 6 degrees, to radians. Because remember, we can only use an angle measure of radians in the arc length formula. So we will convert this to radians by multiplying it by pi over 180 over 180 degrees. And 6 go into both of those. 6 go into 6 one time. 6 goes into 180 30 times, okay? So this actually ends up becoming pi over 30 in radian measure. Yes, that's a 3 right there, okay? And so now we will find our arc length. Our arc length would be r times theta. Our r is 6,400, and that's kilometers. And then our theta is pi over 30. And so this is what we will plug in our calculator. We will do 6,400 times pi and then divide that by 30. And you end up getting your arc length to be approximately 670.2 kilometers. So the distance, this distance right here between Reno and Los Angeles is approximately 670.2 kilometers, okay? So that is how you will use the arc length formula to solve this problem. Let's do another one. Okay, this one's a little different. We have 2 gears that are adjusted so that the smaller gear drives the larger one. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? And we have an image here to help us. So this smaller gear, as it's turning, it is making this larger gear turn. Alrighty. It tells us that the smaller gear turns for 225 degrees. So in order for it to turn 225 degrees, the first thing we need to know is what is the distance that it turned. Okay. So we can use the arc length formula, S equal r theta. But remember, theta has to be in radians. So the first thing we need to do is convert this theta, that's 225 degrees. We need to convert that to radians by multiplying it by pi over 180. If you multiply 225 degrees by pi over 180, that actually reduces down to 5 pi over 4. Okay, 5 pi over 4. And that's because 45 goes into all of those. 45 goes into 225 5 times. It goes into 180 4 times. So our angle in radian measure is 5 pi over 4. So now we can figure out the distance that the smaller gear turns by doing the radius, which is 2.5, and that's centimeters, times 5 pi over 4. So you will plug that in your calculator, 2.5 times 5 pi, and divide that by 4, and you get that the smaller gear turns for approximately, it's going to be 9.817477042. Okay. So now that's important in order for us to be able to calculate how far the larger gear turns. So now we're looking for the arc length on we're looking for the angle, not the arc length. We're looking for the angle theta on the larger gear. So we know the S, the length or the distance that it turns, because it's going to turn the same distance as the smaller one. So we know our S, we know our radius, and so what we want to find is our theta. So if we want to solve for theta, we would divide both sides by r. So our theta is equal to S over r. Our S is this 9.817477042. And then our r is the radius of that larger gear, which is 4.8. And they're both centimeters. So theta is equal, if you divide that out, to approximately 2.0453, I think that's 7717. And that's radians. And it asks for degrees. So notice here it asks for degrees. So what we need to do is convert this to degrees by multiplying this by 180 over pi. Convert that to degrees by multiplying it by 180 over pi. And you get theta to be approximately 117.2 degrees. And so that will be your final answer. And so that is how you will determine how far the larger gear turns. So you first got to figure out how far the smaller one turned. That'll let you know how far the larger one turned. Then you can use that distance to calculate the angle that the larger gear rotated, okay? If you have any questions, put them in the comments and I will respond, all right? Last thing we want to talk about is how to find the area of a sector. The area of a sector, so we found the arc length before, now we want to figure out what is the area of the sector that is formed by that angle, okay? So this shaded region gives us a sector that we want to find the area of, and you'll find that area by using the formula 1/2 times the radius squared times theta, and again, your theta has to be in radian measure. So just like with the arc length formula, with the area formula, you have to use a radian measure, okay? So let's look at one example of this and we'll be finished, okay? So example 4 says we want to find the area of a sector with radius 6 and the arc length is 2 pi, alrighty? So the arc length is 2 pi. So recall that the area is 1/2 times r squared times theta. Now we don't have theta, we have the radius and we have the arc length, but remember the arc length is r times theta. So we can use this arc length formula to find the theta. So our S is 2 pi and our R is 6. So we can solve for theta by dividing both sides by 6. And so this reduces down, 2 goes into 2 one time and it goes into 6 3 times. So we end up getting theta is equal to pi over 3. So now we can use this area formula to find the area. So area is 1/2 of 6 squared times pi over 3. If you multiply that out, you get area is equal to 1/2 of 36 times pi over 3. 1/2 of 36 is 18 times pi over 3. And then 3 goes into 3 once and it goes into 18 6 times. And so you end up getting the area equal to 6 pi, alrighty? Your area is equal to 6 pi. And you can also round that out if you like. And if you plug that in your calculator, let's see what we get. 6 times pi ends up being 18.849. I'll just say 18.85 if we round it to the nearest hundredth, okay? So that's how you will find the area of this circle. So let me know if you have any questions, and I'll see you in the next video.